Welcome to a journey through the deep time and quiet beauty of our planet. As the day gently recedes, we invite you to settle into a space of calm contemplation, allowing your mind to drift and find stillness. Tonight, we embark on an exploration of the earth beneath our feet, delving into the most relaxing geology and rock facts that reveal intricate patterns, subtle wisdom, and profound beauty within the very foundations of our world. This is not a test, nor is there any pressure to remember or retain these details. Instead, let them unfold naturally, inviting your mind to settle into a state of peaceful curiosity. This exploration is designed to be a soothing experience, a gentle current of knowledge flowing without demanding effort or attention. We will observe the intricate dance of minerals forming, the subtle adaptations of rocks to immense pressures, and the quiet wisdom embedded in the slow, patient processes that shape continents and oceans. Each fact is a small window into the vast and interconnected tapestry of geology, presented in a calm and meditative tone, allowing your thoughts to drift and find stillness. Allow the gentle rhythm of these discoveries to guide you towards a state of relaxation, inviting a sense of wonder and peace as you prepare for rest. Let the ancient stories held within stone whisper their timeless truths, calming the busy chatter of the day. If you're finding peace in this journey, a gentle like and subscribe helps us continue creating these restful explorations. And we're always curious. Share in the comments what city and time zone you're watching from. There's something special about knowing this experience is reaching people all over the world as they prepare for rest. Tonight, we begin our geological journey by exploring sedimentary rocks, the Earth's quiet storytellers. These rocks form through the patient accumulation of fragments, layer upon gentle layer, often over millions of years. They capture moments in time, preserving ancient environments and the echoes of a life that once thrived within them. We invite you to contemplate the slow, deliberate processes that give birth to these serene formations. Sedimentary rocks are formed from the accumulation and compaction of sediments, which are fragments of older rocks, minerals, or organic matter. Research shows that these sediments are transported by wind, water, or ice, eventually settling in layers, often in basins or depressions. Over vast stretches of geological time, the weight of overlying layers compacts these sediments, and dissolved minerals cement them together, transforming them into solid rock. This process, known as lithification, is a testament to the Earth's enduring patience. Scientists have observed that sedimentary rocks cover about 75% of the Earth's land surface, though they only constitute a small fraction of the Earth's crust by volume, typically forming a thin veneer over igneous and metamorphic rocks. The distinct layering, or bedding, visible in many sedimentary rocks provides a visual record of successive depositional events, each layer a page in Earth's ancient diary. Current understanding suggests that the slow, steady accumulation allows for the preservation of delicate structures and even the remains of ancient organisms, making them invaluable for studying Earth's past. One of the most widely recognized sedimentary rocks is sandstone, a gentle reminder of ancient shores and riverbeds. Sandstone is primarily composed of sand-sized mineral grains or rock fragments, cemented together. The most common mineral in sandstone is quartz, due to its resistance to weathering, which means it can survive long journeys from its source. Research indicates that the colour of sandstone can vary widely, from white to grey, yellow, red, or brown, depending on the minerals present in the cement or the grains themselves. For instance, iron oxides often impart warm red or brown hues. The rounded nature of many sand grains in sandstone suggests a history of transport by water or wind, as the abrasive action smooths their edges over time. Scientists have observed that ancient desert dunes, river deltas, and shallow marine environments are common places where sandstone forms, each leaving distinct textural and structural clues within the rock. This rock's porous nature allows it to hold water, making it an important aquifer in many regions, silently sustaining life from below. Shale offers a contrasting narrative, representing the quiet settling of the finest particles. This fine-grained sedimentary rock is primarily composed of clay minerals and tiny fragments of other minerals like quartz and feldspar. Shale forms in very calm, low-energy environments where fine mud can settle undisturbed, such as deep ocean basins, lagoons, or slow-moving river floodplains. The characteristic layering, often paper-thin and referred to as fissility, allows shale to split into thin sheets, revealing the delicate nature of its formation. Studies indicate that shale is often rich in organic matter, which under specific conditions of burial and heat can transform into petroleum and natural gas, making it a significant source of energy. The slow deposition rates in these quiet environments also make shale an excellent preserver of fossils, capturing the imprints of ancient leaves, insects, and marine life in exquisite detail. The dark colours often seen in shale suggest the presence of organic carbon, a testament to long-dead organisms that once drifted through ancient waters. Limestone tells a story of the ocean's slow biological breath. It is a sedimentary rock primarily composed of calcium carbonate, often derived from the shells and skeletal remains of marine organisms such as corals, clams, and microscopic plankton. This biogenic origin makes limestone a direct record of past life in the oceans. Research shows that vast quantities of calcium carbonate accumulate on the seafloor as these organisms die, slowly compacting and cementing into rock. Coral reefs, for example, are essentially living limestone factories, building massive structures over millennia that eventually become solid rock. Scientists have observed that limestone can also form through the precipitation of calcium carbonate from water, a process that creates speleothems like stalactites and stalagmites in caves, showcasing the mineral's capacity for intricate growth. The purity of limestone can vary, but its primary component, calcite, reacts with acid, a simple test that reveals its identity. This widespread rock is not only a record of ancient oceans, but also a fundamental resource in modern construction and agriculture. Coal, a unique sedimentary rock, represents compressed sunlight and ancient forests. It forms from the accumulation of plant matter in swampy environments where oxygen is limited, preventing complete decomposition. Over vast periods, this organic material is buried under layers of sediment, subjected to increasing pressure and heat. This process, known as coalification, transforms peat into lignite, then subbituminous coal, and finally anthracite, the highest grade. Research indicates that the energy stored within coal originates from the sun's light, captured by ancient plants through photosynthesis. This stored energy is then released when coal is burned, a powerful reminder of Earth's deep past fueling our present. Scientists have observed that major coal deposits often correspond to periods of extensive swamp forests in Earth's history, such as the Carboniferous period, which earned its name from these vast coal-forming events. The dark, often layered appearance of coal directly reflects its organic origins, a silent testament to the transformation of ancient life into a geological resource. Conglomerate and breccia are clastic sedimentary rocks that speak of more turbulent beginnings, yet their formation ultimately involves quiet settling. Both are composed of large, coarse-grained fragments of other rocks, cemented together by a finer matrix. The distinction lies in the shape of these fragments. Conglomerate contains rounded pebbles, cobbles, or boulders, indicating that the fragments were transported a significant distance by water, allowing their sharp edges to be smoothed. Breccia, on the other hand, consists of angular fragments, suggesting that the material was deposited close to its source, perhaps from a landslide or a fault zone, with little transport. Studies indicate that these rocks provide clues about the high-energy environments where they formed, such as fast-flowing rivers, glacial deposits, or energetic coastlines. Despite their rough components, the final process of cementation is a slow, patient one, where mineral-rich waters percolate through the spaces, binding the fragments into a solid, enduring rock. They are like a mosaic of Earth's past, each fragment a piece of an older story, now bound together in a new narrative. Evaporites are a fascinating class of sedimentary rocks formed from the evaporation of water, leaving behind dissolved minerals. The most common evaporate minerals are halite, rock salt, and gypsum. Research shows that these deposits typically form in arid or semi-arid regions, where bodies of water, such as shallow seas, lagoons, or playas, experience high evaporation rates. As the water evaporates, the concentration of dissolved salts increases until they precipitate out of solution and accumulate on the basin floor. The layering in evaporate deposits can be incredibly fine, reflecting seasonal changes in evaporation and precipitation. Scientists have observed vast deposits of halite and gypsum, sometimes hundreds of meters thick, indicating ancient seas that slowly dried up over geological time. These rocks provide invaluable insights into past climates and ancient hydrological cycles. The silent, almost magical process of water vanishing to reveal hidden mineral structures is a gentle reminder of the Earth's subtle chemistry at play. Diatomite is a light, porous sedimentary rock composed primarily of the fossilized remains of diatoms, which are microscopic, single-celled algae with intricate silica cell walls. These tiny organisms thrive in both freshwater and marine environments, and upon their death, their delicate silica shells sink to the bottom, slowly accumulating over vast periods. The accumulation process is incredibly gentle, allowing the delicate structures of the diatom frustules to be preserved. Research indicates that diatomite deposits often form in calm, nutrient-rich waters where diatom populations flourish. Its unique properties, including high porosity and low density, make it useful in various applications such as filtration, abrasives, and insulation. The rock itself is a testament to the power of the microscopic, revealing how vast geological formations can arise from the gentle, continuous deposition of countless tiny organisms, each contributing its silent, beautiful shell to the Earth's growing archive. The very beginning of sedimentary rock formation lies in the gentle processes of weathering and erosion. Weathering involves the breakdown of existing rocks into smaller fragments or dissolved components, often through physical processes like frost wedging or chemical reactions like dissolution. Erosion then transports these weathered materials away from their source. Research shows that agents of erosion such as wind, water, and ice patiently carve and carry sediments across landscapes. Water, whether in rivers, glaciers, or ocean currents, is a primary mover of sediment, slowly grinding and sorting particles as it flows. Wind also plays a significant role, particularly in arid regions, gently lifting and transporting fine sand and dust. These processes, though sometimes powerful, are often gradual and continuous, subtly reshaping the Earth's surface over vast timescales, preparing the raw materials for future sedimentary layers. Finally, deposition is the quiet settling of these transported sediments. As the energy of the transporting agent decreases, sediments drop out of suspension and accumulate. In a slow-moving river, finer silts and clays will settle in calmer areas, while coarser sands might be deposited on sandbars. In the ocean, fine muds drift to the deep sea floor, far from the energetic currents of the coast. Studies indicate that deposition typically occurs in basins, lakes, rivers, or marine environments, creating distinct layers or beds. The characteristics of these layers, such as grain size, sorting, and composition, provide geologists with clues about the specific depositional environment and the conditions that existed millions of years ago. It is in this patient, silent accumulation that the Earth records its history, each grain a tiny piece of information, gently laid down to form the foundations of future landscapes. As we conclude our first chapter, we are reminded of the Earth's immense patience. Sedimentary rocks with their delicate layers and preserved histories whisper tales of ancient waters, lost forests, and the slow, deliberate rhythm of geological time. They invite us to contemplate the beauty of accumulation, the quiet power of transformation, and the profound stories hidden within the simplest stone. Allow this sense of enduring patience to settle within you, a gentle current of understanding flowing towards tranquility. We have lingered for a while now in the gentle archives of sedimentary rocks, listening to their layered whispers of ancient seas and silent deserts. You have felt the quiet rhythm of deposition, the slow embrace of compaction, and the patient alchemy of cementation, bringing forth stories from fragments of the past. Now, as the soft light of our shared journey deepens, we invite you to turn your gaze inward, to the very core of our planet, to explore the origins of rocks born not of gentle accumulation, but of profound heat and the Earth's molten heart. Imagine, if you will, sinking slowly, effortlessly, beneath the familiar surface of the world. We are descending, not with haste or urgency, but with the quiet grace of a falling feather, through layers of crust, past the foundations of mountains and the roots of continents. Here, in the deep stillness, where the pressures are immense and the temperatures soar beyond comprehension, lies the birthplace of what we call igneous rocks. The very word igneous whispers of fire, of ignition, of a primal genesis. These are the rocks forged in the intense warmth of Earth's interior, born from the cooling and solidification of molten material, a fluid, luminous essence we call magma. This magma, a viscous, often glowing liquid, is not merely a random pool of melted rock. It is a complex blend of minerals, gases, and superheated fluids, constantly in motion, a testament to the Earth's enduring internal engine. Sometimes this magma remains deep within the Earth's crust, finding pockets and chambers where it rests, cooling with an almost unimaginable slowness. It is in these hidden sanctuaries, shielded from the rapid changes of the surface, that the Earth performs one of its most patient acts of creation. As this deep-seated magma begins its long, unhurried descent into solidity, its constituent minerals are given ample time to organize themselves, to grow, to crystallize into forms that are often large enough for our eyes to perceive without aid. These are the intrusive or plutonic igneous rocks, named for Pluto, the ancient god of the underworld, a fitting tribute to their subterranean birth. They are the quiet giants, often unseen until the slow, relentless work of erosion and uplift brings them to the light, revealing their inner beauty to the world. Consider for a moment the steadfast beauty of granite. It is perhaps the most familiar of these deep-borne rocks, a foundational stone of our continental crust. When you gaze upon a piece of granite, you are not merely seeing a rock, you are witnessing a mosaic of Earth's patience. Its characteristic speckled appearance comes from the distinct, interlocking crystals of quartz, feldspar, and mica, each reflecting light in its own unique way. The clear, often glassy grains of quartz speak of purity and strength. The creamy whites, soft greys, or delicate pinks of feldspar tell tales of varying mineral compositions, while the shimmering flakes of mica, whether dark biotite or pale muscovite, add a subtle, almost ethereal sparkle. These crystals, sometimes millimeters, sometimes centimeters across, are tangible proof of granite's slow, deliberate cooling, often over millions of years, deep within the Earth's quiet embrace. We often encounter granite polished smooth, perhaps as a countertop or a monument, and in its cool, reflective surface we can almost feel the ancient pressures and the profound stillness of its formation. It is a rock that embodies stability, strength, and an enduring beauty that time itself has sculpted. But granite is not alone in its subterranean origins. There are other plutonic rocks, each with its own quiet narrative. Diorite, for instance, often presents a striking salt and pepper appearance, a beautiful interplay of dark amphibole and light feldspar crystals, a testament to a slightly different mineral blend and a similar slow, deep cooling. And then there is gabbro, a darker, denser rock, rich in pyroxene and plagioclase feldspar, often forming the lower parts of the oceanic crust, a silent, weighty foundation beneath the vast, rolling waters. These rocks, whether light or dark, coarse-grained or slightly finer, are all children of the deep, born of magma's patient transformation into solid form. Now let us shift our focus, allowing our imaginary descent to reverse as we gently rise towards the Earth's surface. Not all magma remains hidden in the depths. Sometimes, driven by immense pressures and buoyant forces, this molten rock finds pathways, fractures, fissures, volcanic conduits, and begins a journey upward, a slow, determined ascent towards the light. When this molten material breaches the Earth's surface, it transforms. It is no longer magma, it becomes lava. The world above is a stark contrast to the quiet, insulated depths. Here, the air is cool, the water is cold, and the change is swift. Lava, exposed to the elements, cools with a dramatic, often breathtaking rapidity. This sudden environmental shift means that the minerals within the lava have little time to grow into large, discernible crystals. The result is the formation of extrusive or volcanic igneous rocks, named for Vulcan, the Roman god of fire and volcanoes, a deity whose powerful breath shaped the very land. These rocks are the Earth's more immediate, often explosive expressions of its internal energy. But even in their dramatic origins, there is a profound, settling peace that follows. The most common of these surface-borne rocks, a true cornerstone of our planet's outer shell, is basalt. It is a dark, fine-grained rock, often appearing a deep grey or black, sometimes with a subtle green or brown hue. If you hold a piece of basalt, you might notice its smooth, almost velvety texture, the tiny interlocking crystals too small to discern with the naked eye, a whisper of its rapid cooling. Basalt forms the vast majority of our ocean floors, a silent, enduring foundation upon which the great oceans rest. It also creates immense lava flows on land, spreading across vast landscapes in what are known as flood basalts, like the ancient Columbia River basalts in the Pacific Northwest, or the magnificent Deccan traps in India. These vast, dark plains are not merely barren landscapes. They are profound records of Earth's ancient, fiery exhalations, now settled into a deep, enduring stillness. Sometimes, as basaltic lava cools, it contracts in a remarkably orderly fashion, forming intricate geometric patterns of vertical columns, often hexagonal in shape. This phenomenon, known as columnar jointing, creates breathtaking natural sculptures, like the famed Giant's Causeway in Northern Ireland, or Devil's Postpile in California. To stand before these perfectly formed pillars, knowing they were shaped by the simple physics of cooling lava, is to witness the Earth's quiet artistry on a grand scale, a testament to the beautiful order inherent even in powerful molten flows. Not all extrusive rocks are dark and dense like basalt. The speed of cooling and the presence of dissolved gases can create truly unique textures. Take obsidian, for instance. This is a natural volcanic glass, formed when lava cools so rapidly that crystals simply do not have time to form at all. Its surface is smooth, almost liquid in its appearance, and its edges are incredibly sharp, a quality that ancient civilizations utilize for tools and weapons. Gazing into the deep, reflective blackness of obsidian, sometimes streaked with subtle reds or browns, is like looking into a frozen moment of pure molten energy, captured forever in a smooth, dark mirror. Then there is pumice, a rock so light it can float on water. Its secret lies in the abundant gas bubbles that were trapped within the lava as it cooled almost instantaneously, expanding and creating a highly porous, frothy texture. Each tiny void in pumice is a record of a gas bubble escaping from the molten rock, frozen in time, leaving a rock that feels incredibly delicate, yet speaks of the explosive power of its birth. Its light colour, often white or pale grey, further distinguishes it, a stark contrast to the dark basalt, yet both are born of fire. And finally, we might encounter rhyolite, a fine-grained, light-coloured, extrusive rock, often pale pink or grey, which is the volcanic equivalent of granite. It forms from magmas rich in silica, just like granite, but its quick cooling at the surface prevents the formation of large crystals. Rhyolite often indicates more explosive volcanic eruptions, yet in its final, solidified form, it offers a gentle palette of colours, a quiet reflection of its deeper, more patient cousin. In contemplating these igneous rocks, whether they are the deep-seated, patiently formed granites, or the swiftly cooled, surface-borne basalts and obsidians, we are truly connecting with the Earth's foundational story. These rocks are the very bones of our planet, forming the bulk of its crust, shaping the continents we walk upon, and providing the bedrock for the oceans. They are not merely inert stones, they are solidified energy, ancient heat transformed into enduring form. There is no pressure to remember every name, every detail. Instead, we invite you to simply absorb the wonder of these transformations. Feel the deep calm that comes from understanding the Earth's immense power, harnessed and expressed in such diverse and beautiful ways. From the slow, quiet embrace of magma deep within, to the dramatic yet ultimately settling flows of lava across the surface, igneous rocks whisper of beginnings, of the Earth's fiery heart beating through countless eons. They remind us that even the most intense energies can settle into profound stillness, creating structures of immense beauty and strength, foundations upon which all other stories of the Earth are built. Let this understanding settle within you, a gentle warmth, a quiet strength, as you drift into a deeper appreciation for the patient, powerful artistry of our home planet. The journey continues, always with a peaceful heart, always with open wonder. We have journeyed together through the foundational fire of igneous rocks, witnessing their birth from the Earth's molten heart, whether erupting in dramatic display or cooling patiently in subterranean chambers. Now, let us turn our gaze to another profound chapter in Earth's enduring narrative, the quiet, transformative power that gives rise to metamorphic rocks. Imagine, if you will, the deep, silent places within our planet's crust, far beneath the familiar surface. Here, without melting entirely, existing rocks, be they igneous, sedimentary, or even other metamorphic forms, are subjected to immense, unwavering forces. It is a slow, patient alchemy where profound heat, immense pressure, and sometimes chemically active fluids conspire to reshape minerals, alter textures, and birth entirely new rock structures. These are Earth's quiet chameleons, changing form and character in response to the planet's slow, grinding embrace. There is no urgency here, only the deep rhythmic pulse of geological time, inviting us to simply observe and absorb. The very word quote one whispers of change, derived from the Greek meta, change, and morph, form. These rocks are not merely worn down or cooled, they are fundamentally reformed, their internal architecture rearranged, their very essence rescripted by the Earth's profound internal energies. We invite you to release any pressure to remember details, allowing these transformations to simply drift through your mind, like clouds across a vast ancient sky. One of the primary architects of this transformation is heat. This warmth can emanate from deep within the Earth, a residual glow from its formation, or it can be a localized warmth, radiating from a nearby intrusion of molten magma. As temperatures rise, the chemical bonds within existing minerals can loosen, allowing atoms to migrate and recrystallize into new, more stable forms, often growing larger or entirely different crystals than those present in the original rock. It is like a gentle, internal simmer, allowing the constituents to find new harmony. Then there is pressure, a silent, monumental force that can originate from two main sources, Imagine the sheer weight of miles of overlying rock, pressing down evenly from all directions. This is confining pressure. It can compact grains more tightly, reducing porosity and increasing density. But often, the pressure is far more directional, a powerful squeeze from the sides, born of the slow, majestic collision of tectonic plates. This directed pressure is a sculptor of immense power, flattening and elongating mineral grains, aligning them into parallel sheets, creating a distinctive texture known as foliation. Think of it as the Earth's slow-motion hand, pressing and shaping, leaving an indelible record of its immense strength, and sometimes chemically active fluids join this subterranean dance. Often these are hot waters, laden with dissolved ions percolating through the rock, facilitating the transport of material and accelerating chemical reactions. They act as quiet catalysts, helping to dissolve existing minerals and precipitate new ones, subtly altering the rock's composition and texture. It is a slow internal breath, carrying whispers of change through the ancient stone. Together, these forces orchestrate different types of metamorphism, each leaving its own unique imprint. Contact metamorphism, for instance, occurs when hot magma intrudes into cooler country rock. The heat bakes the surrounding rock, causing recrystallization, but often without significant directed pressure. The resulting rocks are typically fine-grained and non-foliated, their transformation a direct consequence of thermal embrace. In contrast, regional metamorphism unfolds over vast areas, often during the grand, slow ballet of mountain building. Here, both intense heat and tremendous directed pressure work in concert, shaping entire mountain ranges, creating rocks that are typically strongly foliated, their minerals aligned in silent testament to the tectonic forces that forged them. This is where we see the Earth's grandest transformations, where continents collide and new landscapes are born from the deep. Let us now gently explore some of these remarkable metamorphic creations, allowing their forms and textures to tell their timeless stories. Consider Festa, slate, a rock born from the humble beginnings of shale, a fine-grained sedimentary rock. Under relatively low temperatures and pressures, a gentle but firm squeeze, the tiny clay minerals in shale reorient themselves, aligning perpendicular to the direction of pressure. This transformation gives slate its characteristic slaty cleavage, allowing it to be split into thin, smooth, remarkably flat sheets. Imagine the quiet strength required to transform soft mud into such a durable, elegant material, used for centuries as roofing tiles or writing tablets. It is a testament to resilience, a quiet strength emerging from quiet beginnings. As the metamorphic grade increases, meaning greater heat and pressure, slate can transform further into phyllite. Here, the microscopic mica crystals begin to grow slightly larger, large enough to impart a subtle, satiny sheen to the rock's surface, a delicate glimmer that distinguishes it from the duller slate. This sheen, often described as a phylitic luster, is like a quiet whisper of increased transformation, a hint of the deeper changes yet to come. The foliation is still present, often undulating gently, like soft drapery. With even more intense heat and pressure, phyllite gives way to schist. In schist, the platy minerals like mica, muscovite or biotite, chlorite or talc, have grown significantly larger, often visible to the naked eye, and are strongly aligned. This alignment creates a distinctive texture called schistosity. giving the rock a shimmering, scaly or flaky appearance. Imagine a rock that sparkled with internal light, its surface a tapestry woven from countless tiny mirrors, each reflecting the immense forces that shaped it. Schist can derive from various parent rocks, including shale, basalt, or even other igneous rocks, each transformation a unique journey through Earth's deep time. At the very highest grades of regional metamorphism, we encounter gneiss, pronounced quote 3. Gneiss is truly a masterpiece of Earth's transformative art, characterized by its striking gneissic banding. Here, light-colored minerals like quartz and feldspar, and dark-colored minerals like biotite and hornblende, have segregated into distinct, wavy, often alternating bands. This separation of minerals is a powerful testament to the extreme temperatures and pressures endured, allowing elements to migrate and coalesce into their preferred layers. Gneiss can form from a wide variety of parent rocks, including granite, shale, or volcanic rocks, each journey culminating in this bold, sweeping display of Earth's immense power and artistic flair. To gaze upon gneiss is to see the very flow of geological time made solid, a frozen moment of immense, slow motion. Not all metamorphic rocks exhibit foliation. Some are non-foliated, meaning their minerals do not show a preferred orientation. This often occurs when the metamorphism is dominated by confining pressure or contact metamorphism, where heat is the primary agent rather than directed pressure. One of the most familiar non-foliated rocks is marble. Born from the gentle calcium carbonate-rich sediments of limestone, or its cousin dolostone, marble undergoes a complete recrystallization of its original calcite or dolomite grains. Under heat and pressure, these tiny grains grow and interlock, forming a denser, more cohesive rock. The delicate structures of the original limestone are erased, replaced by a luminous, crystalline beauty. Marble can be pure white, or it can display exquisite swirls and veins of colour, hints of impurities like clay, iron oxides, or organic matter, transformed into new mineral pigments. It is a memory of ancient seas, made solid and eternally beautiful, a testament to the fact that even the softest sediments can achieve enduring strength and grace. Another remarkable non-foliated rock is quartzite. This incredibly hard and durable rock is the metamorphic product of quartz-rich sandstone. Under intense heat and pressure, the individual quartz grains within the sandstone recrystallize and interlock, often fusing together so completely that the original grain boundaries are obliterated. The resulting rock is far more resilient than its sandy parent, breaking through the quartz grains rather than along their boundaries. Quartzite stands as a symbol of unyielding strength, a rock that has found its ultimate resolve, capable of withstanding the harshest of erosional forces. We might also encounter serpentinite, often a beautiful slippery-feeling rock, typically green or mottled green, formed from the metamorphism of ultramafic igneous rocks, those rich in magnesium and iron. Its name comes from its often mottled snakeskin-like appearance, and near igneous intrusions where contact metamorphism has occurred, we might find hornfels, a fine-grained, dark, dense, non-foliated rock, typically very tough, whose texture is a direct result of being, quote 4, by intense heat. As we gently drift through these images of transformation, we are reminded that geology is not merely about static forms, but about dynamic processes. Metamorphic rocks are the silent witnesses to Earth's most profound internal workings, the slow dance of tectonic plates, the deep well springs of heat, and the patient alchemical power of pressure. They speak of mountain ranges rising and falling, of ancient ocean floors being recycled, and of the fundamental interconnectedness of all rock types within the grand eternal rock cycle. There is no need to grasp or hold on to these names or processes. Simply allow the sense of wonder, the quiet awe at Earth's immense patience and power, to settle within you. Feel the deep calm that comes from contemplating such vast, slow, transformative forces. These rocks, in their quiet stillness, invite us to embrace change, to understand that even under immense pressure, beauty and strength can emerge, reformed and renewed. May this journey into the heart of metamorphic change leave you with a profound sense of peace and a deeper connection to the quiet, enduring wisdom of our planet. We have journeyed through the quiet stories of sedimentary rocks, felt the ancient fire within igneous formations, and witnessed the profound transformation that gives birth to metamorphic wonders. We have seen how Earth, in its immense patience, reshapes and reworks its very substance, a testament to a deep internal wisdom. Now, let us gently draw back the veil a little further, to perceive the grand, continuous dance that unites all these processes, the rock cycle. Imagine, if you will, not a static world of fixed mountains and unchanging valleys, but a vast slow-motion ballet where every stone, every grain of sand, every molten whisper from the deep plays its part in an eternal, transformative rhythm. The rock cycle is not a beginning or an end, but a perpetual flow, a testament to the Earth's ceaseless breath, its slow, deliberate heartbeat echoing through the eons. There is no pressure to recall every detail, merely an invitation to bask in the quiet wonder of this unending journey. Think of a majestic river, always moving, always changing, yet always remaining the river. So too is the rock cycle. It is the Earth's way of recycling its materials, ensuring that nothing is truly lost, only beautifully reshaped. We begin perhaps with the fiery birth of igneous rocks, deep beneath the crust or in a spectacular volcanic eruption. Picture the molten magma, a liquid heart of the Earth, cooling and solidifying into granite, basalt, or obsidian. These rocks, once solidified, are not destined to remain forever in their original form. No, the surface of our planet is a realm of constant interaction, where the gentle touch of wind, the persistent caress of water, and the subtle shift of temperatures begin their patient work. This is the realm of weathering, slowly breaking down the sturdy igneous rock into smaller fragments, grains of sand, particles of clay, dissolved minerals. Then comes erosion, a graceful transport system carrying these sediments across vast distances. Think of a tiny grain of quartz, once part of a granite mountain, now tumbling in a river, carried by a glacier, or swept by desert winds, on its slow journey toward a new resting place. These sediments eventually settle. They drift down into the quiet depths of an ancient ocean, accumulate in a sprawling lake bed, or pile up in vast desert dunes. Layer upon patient layer they gather, and over immeasurable stretches of time, the weight of the overlying material begins to press down, compacting them. Water, rich with dissolved minerals, seeps through, cementing these fragments together, knitting them into new cohesive forms. This is lithification, the quiet alchemy that transforms loose sediment into sedimentary rocks, the sand becoming sandstone, the clay becoming shale, the shells of ancient creatures forming limestone. These are the Earth's patient historians, holding within their delicate strata the whispers of past environments, ancient life, and forgotten landscapes. But the journey does not end there. These newly formed sedimentary rocks, once resting peacefully, may find themselves drawn into the Earth's deeper embrace. As continents slowly drift and collide, as mountains are born from immense pressures, these rocks are subjected to incredible forces. They are buried deeper and deeper, warmed by the Earth's internal heat, squeezed by the weight of miles of overlying rock, and sometimes permeated by chemically active fluids. It is under these profound conditions, without melting entirely, that they undergo a profound internal restructuring. Their minerals recrystallize, their textures change, and their very fabric is transformed. This, as we have explored, is metamorphism, and the resulting metamorphic rocks. Slate, schist, gneiss, marble, quartzite bear the exquisite marks of this intense transformation, often displaying intricate patterns of foliation or crystalline beauty. And what then for these resilient metamorphic rocks? Their journey too is far from over. If they are buried even deeper, if the temperatures and pressures become extreme enough, they may eventually reach a point where they begin to melt. Slowly, gracefully, they return to the molten state, becoming magma once more. This magma in turn may rise and cool, solidifying into new igneous rocks, thus completing a magnificent unbroken circle. Yet, it's important to remember that this cycle is not a rigid linear path. A sedimentary rock once formed might be uplifted and immediately weathered and eroded again, never experiencing metamorphism. An igneous rock might be subjected to heat and pressure, transforming directly into a metamorphic rock without first becoming sediment. It is a fluid, dynamic system, where pathways diverge and converge, where every rock holds the potential for transformation, for rebirth. It is a testament to the Earth's profound patience, its endless capacity for renewal, for telling its story in countless varied forms. What immense force, you might wonder, orchestrates this grand, continuous dance? What drives the slow, majestic flow of the rock cycle, pushing continents, raising mountains, and melting ancient crust? The answer lies in the deep, powerful currents beneath our feet, in the slow, inexorable movements of plate tectonics. Imagine our Earth not as a solid, unmoving sphere, but as a vast, intricate puzzle, its outer shell, the lithosphere, broken into enormous, irregular pieces called tectonic plates. These plates, which carry both continents and ocean basins, are not static. They are in constant, if imperceptibly slow motion, gliding across the semi-fluid layer beneath them, the asthenosphere, driven by the immense heat and convection currents within the Earth's mantle. This is the Earth's true engine, the silent, powerful force that shapes our world and propels the rock cycle. Consider the places where these plates meet, their boundaries. These are the dynamic theatres where much of Earth's geological drama unfolds, where plates pull apart at divergent boundaries. Often beneath the oceans, magma from the mantle rises to fill the gap. Here, new oceanic crust is continuously created as this molten material cools and solidifies, forming vast quantities of igneous rocks like basalt. This process, known as seafloor spreading, is a constant wellspring of new rock material, pushing the plates outward ever so slowly. Then there are the places where plates collide, at convergent boundaries. These are zones of immense compression and transformation. When an oceanic plate, denser and heavier, meets a continental plate, it often plunges beneath it in a process called subduction. As the oceanic plate descends into the mantle, it carries with it sediments and old crust, subjecting them to increasing heat and pressure. Here, rocks are profoundly transformed through regional metamorphism, giving rise to schists and gneisses, and some of the descending material may even melt, generating magma that rises to form volcanic mountain ranges on the overriding plate. A new birth of igneous rocks. When two continental plates collide, neither can easily subduct. Instead, they crumple and fold, pushing up colossal mountain ranges like the Himalayas. These immense forces lead to widespread regional metamorphism, creating vast belts of transformed rocks. The uplift of these mountains then exposes these rocks to the relentless forces of weathering and erosion, sending their fragments on the journey to become new sedimentary rocks. Even where plates slide past each other, at transform boundaries, the friction and stress can cause localized deformation and fracturing, though their direct role in forming new rock types is less pronounced. Yet, even here, the energy of Earth's internal movements is palpable, manifesting in earthquakes, a reminder of the slow, powerful grind beneath our feet. So, you see, the rock cycle is not merely a theoretical concept. It is the observable manifestation of Earth's deep internal energy, driven by the grand architecture of plate tectonics. The very ground beneath us is a testament to these continuous interlocking processes. The mountains we gaze upon, the sands on our beaches, the bedrock that forms our continents, all are participants in this magnificent, unending transformation. As we rest within this understanding, we find a profound reassurance. The Earth is a living, breathing entity, constantly renewing itself, recycling its materials with infinite patience. There is a deep stillness in knowing that the rocks around us, though seemingly inert, are part of a dynamic, eternal ballet, a quiet symphony of creation, destruction, and rebirth. This awareness can bring a deep sense of peace, a quiet connection to the ancient, enduring heart of our planet. Allow this rhythm, this slow, steady pulse of geological time, to settle within you, inviting a profound calm. We have journeyed through the grand, perpetual dance of the rock cycle, witnessing the Earth's profound ability to reshape and renew itself through the slow, inexorable forces of plate tectonics. We've seen how mountains rise and fall, how continents drift, and how the very fabric of our world is constantly, patiently being reformed. Now, as we settle deeper into this quiet contemplation, we invite you to draw your gaze inward, to the very building blocks of these magnificent structures, to the intricate details that compose the grand tapestry of stone. We turn our attention, gently, to the world of minerals. Imagine, if you will, the Earth not just as a canvas, but as a vast, ancient atelier, where countless tiny artists work in perfect harmony, each crafting their unique form with exquisite precision. These artists are the minerals, the fundamental components that give rocks their character, their colour, and their strength. They are the quiet, crystalline whispers within the Earth's stony heart, each one a testament to patience and perfect order. What, then, is a mineral? We might think of it simply as a naturally occurring inorganic solid, possessing a definite chemical composition and, crucially, a highly ordered internal atomic structure, which we call a crystalline structure. Unlike rocks, which are often aggregates of several different minerals, a mineral is a pure, distinct substance. Think of it as a single, perfectly formed word in the Earth's ancient language, while a rock is a sentence or even an entire paragraph composed of many such words. The formation of these crystalline structures is a process of profound stillness and slow, deliberate growth. Deep within the Earth, or within cooling magmatic chambers, or even from the gentle evaporation of ancient seas, atoms arrange themselves with incredible precision. Imagine individual atoms, like tiny invisible dancers, slowly finding their partners and taking their places in a vast three-dimensional lattice. This is not a rushed process, it is a meditation in molecular architecture. The conditions must be just right: the temperature, the pressure, the available space, and, most importantly, the gift of immense time. When these conditions are stable and generous, minerals can grow into exquisite, perfectly formed crystals, showcasing their inherent geometric beauty. Consider the hexagonal prisms of quartz, so often seen in serene, clear points, each facet a mirror reflecting the Earth's quiet light, or the delicate sheet-like structures of mica, peeling away in paper-thin layers, revealing the internal planes of atomic weakness. Think of the perfect cubes of halite, common table salt forming in ancient evaporating basins, each angle a precise 90 degrees, a testament to its internal cubic symmetry. These are not random shapes, but the outward expression of an inner invisible order, a harmony so fundamental it underlies all matter. We can appreciate these minerals not just for their hidden structure, but for the ways they present themselves to us, their gentle properties speaking volumes about their journey. We might first notice their colour, a vibrant spectrum born from their chemical makeup or from tiny impurities, like the deep violet of amethyst, a variety of quartz, or the gentle greens of malachite. Yet colour can be deceptive, a mineral's outward costume. More reliably, we observe its lustre, the way light reflects from its surface. Is it metallic, like the glint of polished silver, or vitreous, like the clear sheen of glass? Perhaps it's pearly, like the inside of a seashell, or dull, absorbing the light into its quiet depths. Each lustre tells us a little more about its surface, its interaction with the world. Then there is hardness, the mineral's resistance to scratching, a quiet measure of its internal bonds. We don't need to memorize the Mohs scale, but simply appreciate that some minerals, like the soft, delicate talc, yield easily to a fingernail, while others, like the unyielding diamond, stand as the Earth's most formidable testament to strength. And how they break, their cleavage or fracture reveals even more of their inner world. Some minerals cleave, breaking cleanly along smooth, flat planes, echoes of their internal atomic alignment. Others fracture irregularly, conchoidally like glass, or splintery, revealing no inherent weakness, only the random force that overcame their strength. Even the streak, the colour of a mineral's powder when rubbed across an unglazed porcelain plate, offers a truer, less variable colour, a subtle revelation of its essence. These properties are not tasks for memorization, but gentle invitations to observe, to appreciate the unique identity of each mineral. They are the subtle expressions of the Earth's quiet artistry, inviting us to look closer, to see the beauty in the fundamental. While there are thousands of known minerals, a select few are particularly abundant and form the bulk of the Earth's crust, earning them the name Quote, FOV. The most prevalent group are the silicates, built around the silicon-oxygen tetrahedron, a small pyramid-like structure that forms the backbone of countless minerals. Within this vast family, we find the ubiquitous quartz with its serene clarity, the feldspars, forming nearly half of the Earth's crust in their soft whites, pinks, and greys, the micas with their delicate, shimmering sheets, and the darker, denser amphiboles, pyroxenes, and olivine, which lend their deep greens and blacks to many igneous rocks. Beyond the silicates, we encounter the carbonates, like calcite, the primary component of limestone and marble, often forming in ancient seas from the shells of marine organisms. There are the oxides D, like hematite, which paints our deserts red, and magnetite with its mysterious magnetic pull. We find the sulfides, like pyrite, the Kea quote Zustis 6, glittering with metallic promise, and the hyosulfates, like gypsum, forming delicate alabaster, or the expansive layers of evaporate deposits, and then the rare and exquisite native elements, like pure gold, silver, and the carbon of diamond found in their uncombined elemental forms, shining with an intrinsic brilliance. Each mineral, whether common or rare, possesses a unique beauty. Picture the breathtaking amethyst geodes, hollow rock cathedrals lined with countless violet crystal points, silent sanctuaries of crystalline growth. Imagine the perfect brassy cubes of pyrite, often found embedded in ancient shales, looking like tiny metallic gifts from the earth. Or the vibrant emerald green crystals of malachite, swirling with intricate patterns born from the slow transformation of copper ores. These are the earth's jewels, not merely for adornment, but as profound expressions of order, time, and patient artistry. As we contemplate the slow, deliberate formation of a single, perfect crystal, we are reminded once again of the immense patience of our planet. This patience is not merely a virtue, but a fundamental dimension of Earth's existence. Geological time, often referred to as deep time, it is a concept so vast, so encompassing, that our human minds, accustomed to the fleeting moments of a single lifetime, can only grasp it through metaphor and quiet contemplation. We have spoken of processes that take millions of years, the uplift of mountains, the drift of continents, the cycling of rocks. But what does a million years truly mean? Our written history spans a mere few millennia. The age of humanity is perhaps a few 100,000 years. The Earth, however, has been patiently evolving for approximately 4.54 billion years. To truly appreciate this scale, let us imagine the entire history of our planet, from its fiery birth to this very moment, compressed into a single, quiet day. A mere 24 hours. In this cosmic day, the Earth would have formed around midnight. The first whispers of life would not appear until well into the morning, perhaps 4 or 5 a.m. The vast majority of this day, the Precambrian eon, would pass in a slow, almost imperceptible unfolding, dominated by microscopic life. The quiet preparation for what was to come. It would be late afternoon, around 4 or 5 p.m. before the first complex marine life emerged. Creatures with shells and skeletons. Dinosaurs, those magnificent ancient beings, would grace the Earth for a relatively brief window, appearing around 10:45 p.m. and vanishing by 11:40 p.m., a mere hour and a quarter in our compressed day. The first mammals would then begin their quiet ascent, and humanity in its current form would not appear until the last few minutes of this day, perhaps the very last second before midnight. All of recorded history, all the triumphs and struggles of civilization would flash by in the final blink of an eye. This is deep time. It is the canvas upon which all the geological processes we have explored, the weathering of mountains, the deposition of sediments, the slow creep of tectonic plates, the growth of a single perfect crystal unfold. It is the secret ingredient that allows the seemingly impossible to become reality. Over eons, mountains erode into sand, vast oceans open and close, and entire species rise, flourish, and gently recede into the fossil record. The Precambrian eon, spanning nearly 4 billion years, represents a time of immense planetary formation and the earliest, simplest life. A time when the Earth was slowly, patiently, preparing for the complexity to come. The Paleozoic era, following the Precambrian, saw the explosion of diverse marine life, the colonization of land by plants and then animals, and the formation of vast coal swamps. The Mesozoic era, the middle life, is famously the age of dinosaurs, but also the time of the first flowering plants and mammals. And finally, the Cenozoic era, our recent life, has witnessed the rise of mammals to dominance, the shaping of modern continents, and eventually the emergence of our own species. There is no pressure to remember these names or dates, only to feel the profound peace that comes from contemplating such immense timescales. Deep time is not merely a scientific concept, it is a spiritual one. It reminds us of the Earth's enduring wisdom, its boundless patience, and the gentle, unhurried rhythm of its existence. It places our own brief lives within a grander, more ancient narrative, inviting us to release the urgency of the moment and find solace in the vast, slow unfolding of planetary history. As you consider the intricate beauty of a single mineral crystal, born of slow growth and perfect order, and then expand that contemplation to the billions of years required for continents to drift and mountains to wear down, allow a profound sense of calm to settle within you. The Earth does not rush. It simply is, transforming, creating, and patiently telling its story through the quiet language of minerals and the majestic sweep of deep time. Rest now, knowing that you are a part of this ancient ongoing narrative, held gently within the Earth's enduring embrace. The profound mystery, the endless contemplation that deep time invites, often leads us to look outward, to the vastness of continents shifting or upward, to the slow dance of mountains reaching for the sky. Yet sometimes the most exquisite revelations, the most soothing truths, are found not in the grand panoramas, but in the quiet hidden spaces beneath our very feet. It is there in the Earth's silent, cool embrace that we discover another testament to its boundless patience, its intricate artistry, and its gentle, persistent power, the world of caves and karst. Imagine, if you will, a journey not across sunlit plains or through ancient forests, but downward into a realm where time itself seems to slow, where the very air is still and cool, carrying the faint earthy scent of ancient stone and mineral-rich water. We invite you now to step with us, gently, into this subterranean sanctuary, a place sculpted not by fire or immense pressure, but by the soft, persistent touch of water over epochs. Here, the earth reveals its hidden stories, whispered in the delicate formations that grow in the eternal darkness, illuminated only by the light of our shared wonder. Karst topography, as scientists have observed, is a landscape born of dissolution, a surface shaped by the slow, chemical breath of water interacting with soluble bedrock, most commonly limestone but also dolomite, gypsum or even salt. It is a testament to the idea that even the most subtle forces, given enough time, can carve out wonders of breathtaking scale and intricate detail. We see it in the sinkholes that pockmark certain regions, the disappearing rivers that vanish into the ground, and most profoundly, in the labyrinthine systems of caves that lie beneath. There is no urgency in this process, only an enduring, quiet persistence, a testament to the Earth's own deep, unhurried rhythm. Think of rainwater falling from the sky, pure and clear. As it descends through the atmosphere, it gathers a whisper of carbon dioxide, a gentle, natural embrace that transforms it into a very weak carbonic acid. This delicate solution, no more aggressive than the softest morning dew, then begins its patient work as it seeps into the ground. It finds its way through the tiniest cracks, the most microscopic fissures in the limestone bedrock, pathways that might seem insignificant, almost invisible to the hurried eye. But to the enduring patience of water, these are not obstacles, but invitations. Over countless millennia, this slightly acidic water begins to dissolve the calcium carbonate that forms the very fabric of limestone. Molecule by molecule, grain by grain, the rock slowly yields, not with a violent crack or a sudden rupture, but with a quiet, continuous release. The tiny cracks widen into slender channels. The channels merge into conduits, and these conduits, over eons, expand into vast echoing passages and chambers. It is a process that mirrors the slow unfolding of a dream, where the solid world transforms into something ethereal, sculpted by an unseen hand. We are watching, in effect, the earth breathing, slowly, deeply, as it draws water into its depths and exhales the dissolved minerals, carrying them away to eventually be redeposited elsewhere, perhaps forming new sedimentary layers in some distant ocean basin. This cycle, this patient exchange, is at the heart of cave formation. Subterranean rivers begin to flow through these newly formed passages, carving them larger, deeper, connecting them into intricate networks, silent arteries through the Earth's ancient body. Sometimes these rivers form vast, still lakes, reflecting the profound darkness in their glassy surfaces, creating an illusion of infinite space, a mirror to the quiet contemplation within us. And within these silent, dark cathedrals, another form of artistry unfolds, perhaps the most delicate and wondrous of all, the growth of speleothems. These are the mineral formations, the exquisite decorations that adorn the ceilings, floors, and walls of caves, each one a testament to the slow, steady drip of water and the patient crystallization of minerals. They are Earth's quiet storytellers, each curve and facet holding the memory of countless passing moments, each infinitesimal layer a record of ancient rains and the passage of deep time. Look upward, if you will, and observe the stalactites, those elegant, elongated fingers of stone that hang from the cave ceiling like inverted icicles. They form as mineral-rich water, supersaturated with calcium carbonate, seeps through the bedrock and emerges onto the cave roof. As each tiny drop hangs suspended, exposed to the cave air, a minute amount of carbon dioxide escapes, causing a whisper of calcium carbonate to precipitate out. When the drop finally falls, it leaves behind an almost imperceptible ring of calcite, adding to the length of the stalactite. It is the Earth's slow tears, falling over thousands, even hundreds of thousands of years, each tear contributing to a masterpiece of quiet, enduring beauty. And directly below, as these drops fall to the cave floor, another miracle begins to grow, the stalagmite. Here, the process is reversed, yet equally patient. The falling drops, still laden with minerals, impact the floor, releasing more carbon dioxide and depositing their tiny loads of calcite. Slowly, steadily, year after year, century after century, a mound begins to rise, growing upward, reaching ever so gently towards the stalactite above. It is a patient upward reach, a silent aspiration, a testament to the Earth's own profound sense of balance and harmony. Sometimes, over vast stretches of time, the stalactite descending from above and the stalagmite rising from below meet in a timeless embrace, forming a grand, majestic column. These pillars of stone stand as silent sentinels, connecting the ceiling to the floor, embodying the full span of the cave's patient formation, a geological handshake across deep time. They are monuments to the quiet perseverance of water and mineral, standing firm in the eternal darkness, inviting us to reflect on the enduring nature of connection and growth. Beyond these more familiar forms, we find other exquisite expressions of the Earth's subterranean artistry. There are flowstones, smooth, cascading sheets of calcite that coat cave walls and floors, forming as mineral-rich water flows gently over surfaces, leaving behind layers of crystalline beauty. They resemble frozen waterfalls, draperies of stone, each ripple and fold capturing the memory of ancient currents, a silent choreography of mineral deposition. And then there are the delicate, often gravity-defying helictites, thin, twisting, almost whimsical formations that seem to grow in every direction, defying the simple pull of gravity, as if the minerals themselves are whispering their own unique stories, unfettered by conventional laws. Scientists believe their irregular growth is influenced by capillary action and subtle air currents, making them truly unique expressions of geological serendipity. The atmosphere within these subterranean worlds is profoundly soothing. The air is often cool and constant, untouched by the fluctuations of the outside world. Sound is absorbed by the dense rock, creating a profound stillness, a silence that can be deeply restorative. In this quiet dark, our other senses become more attuned. The subtle scent of damp earth, the cool touch of the air on our skin, the profound absence of visual distraction. It is a space where the mind can truly rest, where the ceaseless chatter of daily life can fade, replaced by a deep sense of calm and wonder. Here, we are not merely observers, but participants in a timeless stillness, connected to the Earth's most ancient, patient rhythms. Every millimetre of growth in these formations represents centuries, sometimes millennia, of patient deposition. A stalactite just a few inches long might be thousands of years old, while a massive column could have been growing for 1 million years or more. This is deep time rendered tangible, visible in the slow incremental accretion of mineral upon mineral. It reminds us that true transformation, true beauty, often requires immense patience and an unhurried pace. There is no rush, no urgency, only the steady, persistent unfolding of geological processes. As we gently bring our minds back from these hidden depths, we carry with us the profound impression of the cave's quiet wisdom. It is a wisdom that speaks of enduring beauty born from the simplest elements, water, rock, and time. It reminds us that even in darkness, intricate patterns can emerge, that even in stillness, profound growth occurs, and that the earth, in its silent, continuous work, is always creating wonders, both seen and unseen. The subterranean world of karst and caves is a gentle invitation to contemplation, a reminder that the most powerful forces are often the most subtle and persistent. It is a place where the earth breathes its quiet, ancient breath, where minerals dance in slow motion, and where the profound silence offers a sanctuary for the soul. We are left with a renewed sense of awe for our planet's hidden artistry, a deeper appreciation for the patience of geological time, and a quiet understanding that true beauty often lies in the slow, unhurried unfolding of life, just as it does in the formation of these magnificent silent spaces beneath our feet. This continuous quiet artistry, always at work, remains a profound mystery, inviting endless contemplation, even as we return gently to the surface. As we journeyed through the quiet darkness of Earth's subterranean realms, observing the patient genesis of speleothems, we found ourselves immersed in a world shaped by the subtle alchemy of water and stone. Now, we invite you to gently lift your gaze from the depths and turn it towards the vast open canvas of the Earth's surface. Here, too, a profound artistry is at play, a ceaseless, slow dance of forces that sculpt continents, carve valleys, and reshape shorelines with a patience that transcends our fleeting human understanding. Imagine with us, if you will, the exposed face of a mountain, a grand stoic sentinel that has stood for eons. Even this seemingly immutable giant is not beyond the reach of Earth's quiet storytellers. We speak now of weathering, the gentle, persistent process that breaks down rocks, transforming the hard, unyielding stone into smaller, softer fragments. It is the Earth's way of gently loosening its embrace, preparing its ancient materials for new journeys and new forms. Think of mechanical weathering, a process driven by physical forces, yet often unfolding with an almost imperceptible slowness. Consider the delicate yet powerful act of frost wedging. Water, that life-giver and sculptor, seeps into the tiniest cracks and fissures within a rock. As temperatures drop below freezing, this water expands, exerting an incredible pressure, a patient internal push against the surrounding stone. Over countless cycles of freezing and thawing, this gentle expansion widens the cracks, little by little, until eventually pieces of the rock break away. It is a testament to the quiet power of repetition, a whisper that, over deep time, becomes a resounding chorus of transformation. There is no violence here, only the steady, rhythmic breath of the seasons, slowly unbinding the ancient bonds of stone. Then there is the subtle strength of life itself, expressed through root wedging. Imagine the tenacity of a tiny seed, finding purchase in a hairline crack on a rock face. As it germinates and grows, its roots extend, seeking nourishment, and in doing so they exert a quiet, persistent pressure. These living tendrils, soft and yielding, yet imbued with an incredible will to grow, can gradually widen cracks, pushing apart even the most stubborn rock. It is a beautiful metaphor for life's gentle yet unwavering power, a reminder that even the smallest living things participate in the grand geological narrative, patiently reshaping the very foundations of our world. And observe, too, the phenomenon of exfoliation, sometimes called pressure release. Deep within the earth, Rocks are held under immense pressure from the weight of overlying material. When erosion slowly removes this overburden, the pressure on the buried rock is released. The rock, no longer compressed, expands, and in doing so, it often fractures into concentric, onion-like layers that peel away. Imagine the earth taking a slow, deep breath, expanding gently from within, shedding its outer skin in elegant, curved sheets. These smooth, rounded domes, like those seen in Yosemite or Stone Mountain, are monuments to this quiet, expansive release, a testament to the Earth's ability to unburden itself over vast stretches of time. Beyond these physical transformations lies the realm of chemical weathering, where the very composition of rocks is subtly altered, often by the pervasive presence of water and atmospheric gases. It is a slower, more intimate form of change, a gentle alchemy that dissolves and transforms minerals, creating new substances or making them more susceptible to physical breakdown. Recall the dissolution we observed in the formation of karst landscapes and caves, where weakly acidic water slowly eats away at limestone. This same process occurs on the surface, quietly softening and reshaping soluble minerals in many rock types. Water, often made slightly acidic by dissolved carbon dioxide from the atmosphere, becomes a gentle solvent, patiently unlocking the chemical bonds that hold minerals together. It is a subtle, almost imperceptible process, yet over millions of years it can entirely transform landscapes, turning hard rock into soft, pliable soil. Consider oxidation, a process familiar to us as rust. When iron-bearing minerals in rocks are exposed to oxygen in the air or dissolved in water, they react, forming iron oxides. This creates the warm, earthy reds, oranges and browns we see in many desert landscapes and ancient rock formations. It is the Earth's gentle blush, a slow, natural decay that weakens the rock, making it more fragile and prone to further breakdown. This quiet transformation paints entire mountain ranges with hues of sunset, a testament to the slow atmospheric breath of our planet. And then there is hydrolysis, where water molecules themselves react with minerals, breaking them down into new compounds. Feldspars, one of the most abundant mineral groups in the Earth's crust, are particularly susceptible to hydrolysis, slowly transforming into clay minerals. This process is fundamental to the creation of soils, the very foundation of terrestrial life. It is the deep, patient work of water, quietly dismantling ancient structures to build the fertile ground for new growth, a continuous cycle of release and renewal. As rocks are patiently weathered, broken down into smaller fragments, sediments, they do not simply remain in place. They begin a journey, often a long and arduous one, guided by the relentless forces of erosion. Erosion is the Earth's way of moving its materials, a grand transportation system driven by the energy of water, wind, ice, and gravity. It is the dance of removal, carrying away the old to expose the new, and transporting the fragments to new resting places where they will eventually begin their next transformation. Imagine the power and artistry of water, the primary agent of erosion on our planet. Raindrops, seemingly insignificant, can dislodge tiny particles of soil and rock. As these drops coalesce into rivulets, then streams, and finally mighty rivers, they gain immense power. Rivers are the Earth's great sculptors, patiently carving canyons that plunge thousands of feet deep, shaping valleys into graceful curves, and transporting vast quantities of sediment from mountains to the sea. Feel the steady rhythmic flow of a river, carrying its burden of sand, silt and clay, each grain a tiny piece of an ancient mountain on its way to a new destiny. This ceaseless flow is a profound reminder of the Earth's continuous motion, a gentle yet powerful current of change. The ocean, too, is a powerful sculptor. Waves tirelessly batter coastlines, breaking down cliffs and shaping beaches. The relentless surge and retreat of the tides, the current sweeping along the seafloor, all contribute to the redistribution of sediments, carving submarine canyons and shifting vast quantities of material across the continental shelves. It is a vast watery ballet, an unending performance of creation and destruction, where the land yields to the sea, and the sea in turn reshapes the land. Then there is wind, the invisible artist. In arid regions where vegetation is sparse and sediments are dry, wind becomes a significant agent of erosion. It lifts fine particles of dust and sand, carrying them across vast distances, sometimes even across oceans. As these sand grains are carried, they abrade and polish exposed rock surfaces, creating intricate patterns and smooth, sculpted forms known as ventifacts. Imagine the desert wind, whispering its ancient stories, gently sanding down the rough edges of time, creating landscapes of ethereal beauty where dunes shift and flow like frozen waves. And let us not forget the immense slow power of ice, manifested in glaciers. These vast rivers of frozen water, born in high mountains or polar regions, move with an almost unimaginable slowness, yet their power is undeniable. As they flow, glaciers pluck away rocks from their beds and sides, incorporate them into their icy mass, and then grind them against the underlying bedrock, creating distinctive U-shaped valleys, cirques, and fjords. The sound of a glacier moving, if one could truly hear it across deep time, would be a low, resonant hum, a gentle yet unstoppable force, reshaping entire mountain ranges with an ancient, patient hand. Finally, there is the ever-present force of gravity, a silent, constant sculptor. Whether in the dramatic rush of a landslide, the slow creep of soil down a gentle slope, or the steady fall of individual rocks from a cliff face, gravity tirelessly pulls all material downwards. These mass-wasting events, though sometimes sudden and powerful, are also part of the Earth's patient process of levelling and reshaping its surface, bringing materials from higher elevations to lower ones, where they can continue their journey. As these weathered fragments are transported by water, wind, ice, and gravity, they eventually come to rest. This brings us to wet deposition, the quiet conclusion of their journey, where sediments are laid down in new locations, building new landscapes and preparing the way for the formation of new rocks. It is a process of settling, of finding stillness after motion, a moment of profound peace in the relentless cycle of change. Imagine the vast deltas where mighty rivers meet the sea, spreading their accumulated load of silt and sand in intricate branching patterns. These are places of immense deposition, where new land is constantly being built, layer upon patient layer. Or picture the serene depths of a lake, where fine particles slowly settle to the bottom, forming soft, muddy beds that will, over deep time, compact into shale. In the deep ocean basins, far from the turbulent shores, a continuous gentle rain of microscopic marine organisms and fine sediments drifts down, accumulating over millions of years to form thick layers of ooze, which will eventually become limestone or chert. Here, the stillness is almost absolute. The process of deposition a quiet, steady accumulation, a testament to the vastness of oceanic time. Even the wind, after its energetic dance, deposits its burden. Sand dunes, those majestic, shifting mountains of sand, are formed by the patient accumulation of wind-blown grains. Lewis, fine, wind-deposited silt, creates fertile plains that cover vast areas, whispering tales of ancient winds and distant sources. And glaciers, after their powerful sculpting, eventually melt, leaving behind vast deposits of unsorted rock and sediment called till, forming features like moraines and drumlins. These chaotic yet beautiful landscapes tell the story of ice's retreat, a silent record of a colder time, now slowly softened by the gentle hand of new life and subsequent weathering. These processes of weathering, erosion, and deposition are not separate events, but a continuous interconnected dance, a grand, perpetual motion on the Earth's surface. They are the patient hands that constantly reshape our world, erasing the old, revealing the new, and always, always preparing the raw materials for the next stage of Earth's deep time story. There is no pressure to remember every detail, only to allow your mind to drift with these images, to feel the quiet power of these forces, and to find a sense of calm in the immense, enduring patience of our planet. For in observing these gentle, ceaseless transformations, we connect with the very rhythm of Earth, a rhythm of profound beauty, subtle wisdom, and enduring peace. As we continue our quiet journey, invited into the Earth's patient narrative, we find ourselves turning our gaze from the general principles of weathering, erosion, and deposition to the magnificent, enduring agents that carry out these transformations. We have felt the subtle whisper of the wind, the gentle touch of rain, and the deep unseen work beneath our feet. Now, let us drift, with the tranquil current of a river, or with the slow, immense grind of ancient ice, to observe how these forces sculpt the very face of our world, drawing forth landscapes of breathtaking beauty and profound peace. Imagine, if you will, the gentle, ceaseless flow of water. We often see rivers as mere conduits, pathways from source to sea, but they are so much more. They are the Earth's quiet arteries, pulsing with life and energy, continuously reshaping the land with an artistry that unfolds over countless millennia. A river, in its serene journey, is both an architect and a sculptor, endlessly carving, transporting, and depositing, telling tales of the mountains it has embraced and the valleys it has cradled. From its humble beginnings as a small stream, perhaps a gentle trickle born from melting snows or a quiet spring, a river gathers strength, its waters finding the path of least resistance. With each drop, it begins its work of erosion. The flowing water, carrying fine grains of sand and silt, acts like a liquid sandpaper, slowly abrading the bedrock of its channel. Over vast stretches of time, this persistent friction deepens and widens its path, carving canyons and valleys that speak of immense patience and unwavering purpose. Think of the Grand Canyon, not as a sudden chasm, but as the accumulated result of the Colorado River's quiet, persistent work over millions of years, a testament to water's enduring power, a vast open book of geological time etched into stone. There is no urgency in this work, only a steady rhythmic progression, a profound dedication to its path. As the river flows, it carries with it the loosened fragments of rock and soil, the very sediments we explored in earlier chapters. Some particles, light and fine, are suspended within the water, drifting along like dust motes in a sunbeam. Others, heavier and coarser, bounce and skip along the riverbed in a dance called saltation, a quiet, rhythmic tapping against the river's floor. The heaviest boulders might simply roll or slide, pulled by the sheer force of the current in a process known as traction. Each grain, each pebble, each stone is on a journey, a slow migration guided by the river's gentle hand, contributing to the grand tapestry of erosion and transport. But rivers are not merely agents of destruction. They are also magnificent creators, laying down the foundations for new landscapes. As the gradient of the land lessens, or as the river widens and its current slows, its capacity to carry sediment diminishes. The heavier particles are the first to settle, followed by the finer silts and clays. This act of deposition is a quiet, continuous process, building up floodplains, those fertile, flat expanses alongside a river that are replenished with new layers of sediment during seasonal overflows. These floodplains, rich in minerals, are like the Earth's own gardens, nourished by the river's generosity. And observe the river's elegant curves, its graceful meanders. As a river flows across flatter terrain, its current erodes the outer banks of its bends, where the water moves faster, while simultaneously depositing sediment on the inner banks, where the current is slower. This subtle, continuous adjustment causes the bends to grow more pronounced, forming sweeping, serpentine loops. Sometimes, in a moment of geological whimsy, two adjacent meanders might erode so deeply into one another that the river cuts a new, straighter path, leaving behind a crescent-shaped body of water, a serene oxbow lake, a quiet relic of the river's former embrace, slowly filling with sediment and returning to the land from which it sprang. Finally, as the river approaches its ultimate destination, a vast lake or the boundless ocean, its current slows dramatically. Here, it relinquishes its entire burden of sediment, spreading it out in intricate fan-like patterns known as deltas. These are places of immense fertility and complex ecosystems, where the land meets the water in a delicate shifting balance. The Mississippi Delta, the Nile Delta. These are not static formations, but living, breathing landscapes, constantly being reshaped by the river's quiet offerings and the ocean's gentle tides. They are places of profound stillness, where the earth pauses to create, laying down layer upon layer of history, a soft, fertile embrace. Now, let us shift our focus from the flowing waters to something even grander, slower, and perhaps even more ancient in its power, the immense patient presence of ice. We speak, of course, of glaciers, those majestic, slow-moving rivers of solid ice that have sculpted vast portions of our planet, leaving an indelible mark that whispers of past epochs and colossal forces. Imagine a place where snow falls, not just for a season, but for centuries, accumulating layer upon layer, never fully melting. As new snow falls, it compresses the older layers beneath. The delicate snowflakes, with their intricate crystalline structures, are gradually transformed. Air is squeezed out, and the snow recrystallizes, becoming denser, turning first into granular firn, and then, over decades or even centuries, into a solid mass of glacial ice. This transformation is a testament to the Earth's profound patience, a slow, quiet alchemy of pressure and time. Once formed, when the ice mass reaches a certain thickness, typically around 150 feet, about 45 meters, its own immense weight causes it to deform and flow, like an unimaginably viscous fluid. This is a glacier, a colossal living entity, moving with a ponderous, majestic slowness that defies our everyday perception of motion. We might not perceive its movement in a single glance, but over days, years, and millennia, a glacier is a tireless sculptor, shaping mountains and valleys with an unparalleled power. The erosional work of a glacier is both brutal and beautiful. As it grinds its way across the landscape, it performs two primary acts of sculpting. First, there is plucking, where the flowing ice freezes onto fractured bedrock, then literally plucks away large blocks of rock as it advances. This process is like a gentle but firm hand, extracting ancient wisdom from the earth. Second, there is abrasion, where the ice, armed with embedded rocks and debris, acts like a giant moving sandpaper, scouring and polishing the underlying bedrock. This leaves behind distinctive striations, long parallel scratches etched into the rock, silent witnesses to the glacier's passage, telling tales of its direction and immense power. The landscapes carved by glaciers are unmistakable and profoundly serene. Unlike the V-shaped valleys sculpted by rivers, glaciers carve broad, sweeping U-shaped valleys, their sides steep and their floors flat, reflecting the immense width of the ice that once filled them. High in the mountains, they carve out bowl-shaped depressions called cirques, often cradling pristine turquoise lakes known as tarns. Where several cirques erode back to back, they can leave behind knife-edge ridges called arêtes, or sharp, pyramidal peaks known as horns, like the iconic Matterhorn, sculpted by the patient hand of ice. And where these glacial valleys meet the sea, they form breathtaking fjords, deep, narrow inlets of water, their steep walls plunging directly into the ocean, silent cathedrals of rock and water, often draped in mist and profound stillness. But glaciers, like rivers, are also generous depositors. As the climate warms, or as a glacier reaches its maximum extent and begins to retreat, it leaves behind the vast quantities of rock and sediment it has collected. This unsorted, unconsolidated mixture of clay, sand, gravel and boulders is known as till. When till is deposited directly by the ice, it forms distinctive landforms called moraines, ridges of debris that mark the glacier's former boundaries. We see terminal moraines at the furthest extent of the ice, lateral moraines along its sides, and comedial moraines, where two glaciers have merged, their internal debris converging into a dark stripe down the centre. These moraines are like the Earth's quiet monuments, commemorating the vast, slow journeys of ice. Other glacial deposits include drumlins, smooth, elongated hills of till, shaped like inverted spoons, often occurring in fields, all aligned in the direction of ice flow, like gentle giants marching across the landscape. And then there are eskers, long, winding ridges of sand and gravel, formed by rivers that once flowed within or beneath the glacier, their beds preserving the ancient water channels even after the ice has melted away. These are the subtle, intricate details of a landscape profoundly shaped by ice, now revealed in the sunlight, inviting quiet contemplation. These glacial features are not just remnants of the past. They are living testaments to the Earth's dynamic history. They speak of vast ice ages, periods when colossal ice sheets covered much of the northern hemisphere, shaping continents and influencing global climates. The memory of these ice ages is etched into the very bedrock beneath our feet. a profound reminder of the immense timescales over which our planet breathes and transforms. As we gently bring our awareness back to this moment, we recognize that the rivers and the glaciers, like all the forces of Earth, are engaged in a ceaseless, majestic ballet of creation and transformation. They remind us that nothing is truly static, that even the most solid rock is subject to the patient, persistent work of water and ice. There is a deep comfort in this understanding, a profound sense of peace in recognizing our place within this grand, enduring cycle. So, let your mind drift with the river's current, or rest in the quiet immensity of a glacial valley. Feel the ancient wisdom embedded in these landscapes, the stories whispered by the rocks, the profound stillness that permeates all deep time. There is no need to remember every detail, only to allow the gentle rhythm of these processes to wash over you, fostering a sense of calm, wonder, and a quiet connection to the enduring heart of our planet. Rest now in this awareness, and let the Earth's quiet artistry continue to soothe your spirit. We have journeyed across the land, tracing the patient paths of rivers, and witnessing the slow, sculpting embrace of glaciers, those colossal, frozen rivers of time. Now let us turn our gaze and our quiet attention to the vast, shimmering expanse that cradles our continents, the ocean. It is an ancient, boundless entity, a rhythmic heart whose ceaseless motion orchestrates some of Earth's most profound and beautiful transformations. Imagine, if you will, standing at the very edge of a continent, where the land meets the sea. Feel the cool breath of the salt-laden air, hear the rhythmic sigh and roar of the waves. This interface, this dynamic frontier, is where the ocean performs its patient, powerful artistry. It is a place of constant change, a testament to water's enduring strength, a realm where the land is perpetually being resculpted, grain by grain, cliff face by cliff face. The most immediate and captivating agents of this oceanic sculpture are the waves. Born from the whisper of wind across vast stretches of open water, they gather energy across thousands of miles, culminating in a magnificent surging power as they approach the shore. Each gentle surge, each distant rumble, is a whisper of immense power, patiently shaping the very edge of the land. Research shows that even seemingly calm waves can exert tons of pressure per square foot on a coastline, and during storms this force becomes truly monumental. Yet, it is not always the dramatic impact that accomplishes the most. Often, it is the persistent rhythmic embrace, the endless repetition over deep time that truly transforms. Consider the rugged coastlines, where towering sea cliffs stand as silent sentinels against the ocean's advance. Here, the waves, armed with the abrasive power of sand, pebbles, and even boulders, relentlessly attack the rock face. They scour and undercut the base of the cliffs, creating notches and caves. Over eons, this persistent embrace carves away the softer layers, leaving behind wave-cut platforms that extend like rocky aprons beneath the sea, exposed only at low tide. We see sea arches, those elegant stony bridges sculpted by waves eroding through headlands, and sea stacks, lonely pillars of rock that once were part of the mainland, now standing isolated as monuments to the ocean's slow, unyielding power. These are not sudden transformations, but the cumulative work of countless waves, each one a tiny chisel, patiently working for millennia. There is a deep peace in contemplating such slow, deliberate change. a quiet understanding of nature's vast patience. And then there are the tides, the ocean's slow, gravitational breath, pulling and pushing the water in a daily rhythm dictated by the moon and sun. While perhaps less dramatic than crashing waves, the tides contribute to the slow dance of erosion and deposition, particularly in estuaries and bays. They gently move sediments, exposing and submerging vast intertidal zones, allowing the subtle forces of weathering, salt crystallization, drying and wetting cycles to further break down rock and soil. Unseen currents too, like silent rivers within the sea, transport fine particles of sediment, slowly redistributing the Earth's weathered fragments across the seafloor. Yet the ocean is not solely a sculptor of removal, it is also a masterful artist of accumulation, creating stretches of serene beauty and intricate geological formations. Think of a beach, that quintessential place of calm and contemplation. A beach is a testament to the ocean's patient sorting, a vast collection of grains, each a tiny fragment of Earth's story, transported and deposited by the rhythmic action of waves and currents. The sand you feel beneath your feet, the smooth pebbles you might pick up, have often travelled vast distances, tumbled and abraded until their edges are softened, their forms perfected by the ocean's gentle caress. The ocean's currents, moving parallel to the shore, perform a slow, continuous dance, carrying sand and sediment along the coastline in a process known as longshore drift. This patient transport builds magnificent depositional features. Imagine the graceful curve of a sand spit, a narrow finger of sand extending into a bay or a barrier island, a long low-lying strip of land parallel to the mainland, protecting quiet lagoons and marshes. These delicate extensions of land are ever-changing, growing and shrinking, migrating with the shifting sands, living embodiments of the ocean's patient constructive power. They are ephemeral in the scale of deep time, yet enduring testaments to the continuous flow of sediment and water. Far from the crashing surf, in the profound stillness of the deep ocean basins, another form of geological artistry unfolds, even more slowly, even more patiently. Here, beneath miles of water, sediments accumulate with an almost unimaginable slowness, layer upon delicate layer, over millions upon millions of years. This quiet accumulation creates a vast, silent archive of Earth's past, a record waiting to be read by the patient hand of science. These deep-sea sediments come from many sources. Some are terrigenous, meaning they originate from land, carried by rivers to the sea, blown by winds or dropped by melting glaciers, slowly settling through the water column. Others are hydrogenous, precipitated directly from the seawater itself, forming unique minerals like manganese nodules, slowly growing on the abyssal plains over millions of years. But perhaps the most wondrous of these deep-sea accumulations are the biogenous sediments, formed from the remains of countless microscopic lives. Imagine tiny single-celled organisms foraminifera with their intricate calcite shells, coccolithophores with their delicate plates, diatoms and radiolarians building exquisite glass-like skeletons of silica, living and dying in the sunlit waters above. When they pass, their tiny shells and skeletons drift down like silent snow settling onto the seafloor. Over vast stretches of time, this snow forms thick layers of calcareous oozes and siliceous oozes, which will eventually, under the immense pressure of overlying layers, compact and cement into future limestones, cherts, and other sedimentary rocks. It is a profound thought. Mountains of rock, formed from the quiet collective breath of microscopic life, a testament to the enduring power of the small and the slow. And in certain warm, sunlit shallows, life itself begins to build geological wonders of an even grander scale, coral reefs. These magnificent structures are not merely collections of rocks. They are living, breathing geological formations sculpted by the patient, collective effort of millions of tiny animals called coral polyps. These small, soft-bodied creatures, in their quiet communities, extract calcium carbonate from the seawater, slowly constructing intricate stony homes and vast interconnected skeletons. A single coral colony grows at a pace measured in millimeters per year, yet collectively over millennia, they erect entire underwater cities, vast and complex ecosystems that rival the most majestic mountain ranges. They are built with an exquisite slowness, layer upon living layer, each generation adding to the monumental structure left by its ancestors. The Great Barrier Reef, for example, is a geological marvel that has been growing for over 20 million years, a testament to the enduring power of biological processes to shape the very crust of the earth. These vibrant living structures are the modern echoes of ancient marine-built limestones we have encountered before, showing us that life itself is a profound geological force, a patient builder of Earth's foundations. The ocean, in its boundless expanse, reminds us of the gentle yet unyielding power of our planet. It is a grand symphony of erosion, transport, deposition, and life's quiet construction, all unfolding with an ancient rhythm that has echoed for billions of years. From the crashing waves that sculpt dramatic coastlines to the silent snowfall of microscopic shells in the deepest trenches, the ocean is a testament to immense patience, to the slow, steady transformation of Earth's surface. Allow these images to drift gently through your mind, the rhythmic pulse of the waves, the slow dance of tides, the quiet journey of a single grain of sand, the silent descent of a tiny shell, the slow, intricate growth of a coral reef. There is no pressure to remember every detail, no need to retain every fact. Simply allow the quiet understanding of Earth's oceanic processes, its profound patience and its ceaseless gentle energy to settle within you, bringing with it a deep sense of calm and connection to our wondrous, ever-changing world. Rest now in the quiet contemplation of the ocean's timeless story. As the mighty currents of the oceans continue their tireless dance, shaping coastlines and nurturing the vibrant coral cities beneath the waves, we turn our gaze, gently now, inward and downward, into the very heart of Earth's silent archives. For beneath the layers of sand and silt, within the hardened embrace of ancient muds and limestones, lie the most poignant of Earth's storytellers, the fossils. They are not merely remnants, you see, but the petrified poetry of existence, the quiet echoes of lives lived eons ago, preserved with an exquisite patience that only our planet truly understands. Imagine, if you will, the soft rhythmic hush of time unfolding, layer upon delicate layer, each one a page in an immeasurable book. Fossils are the indelible script upon these pages, the signatures of beings that once swam in primordial seas, soared through ancient skies, or rooted themselves deeply in long-vanished soils. They whisper of a world that was, a world teeming with forms both familiar and utterly alien, each breath, each movement, each quiet cycle of life and death, slowly, miraculously, transcribed into stone. There is no pressure to decipher every line, no need to remember every name. Simply allow the profound beauty of this ancient inscription to wash over you, a soothing testament to life's enduring journey. The process by which these miracles occur is itself a testament to Earth's gentle, relentless persistence. Fossilization is not a common event, it is a rare and precious gift, requiring a precise alignment of circumstances, a quiet choreography of decay and preservation. For an organism to become a fossil, its remains must typically be protected very quickly from the scavengers and the elements that would otherwise reclaim it. Imagine a delicate leaf falling into a quiet, oxygen-poor swamp, or a creature sinking into the soft, silty bottom of a calm lake, or perhaps a shell being swiftly buried by a sudden influx of sediment. This swift burial is often the first crucial step, sealing the remains away from the bustling world of decomposition. Once buried, the slow, patient work of mineral replacement begins. As groundwater, rich with dissolved minerals, seeps through the surrounding sediments and the buried remains, it gradually replaces the organic material, molecule by molecule, with minerals like silica, calcite, or pyrite. This process, known as permineralization, transforms the original structure into stone, preserving even the most intricate details, the delicate cell walls of a plant, the microscopic pores of a bone. It is a transformation of exquisite slowness, often taking millions of years, an unhurried alchemy where the fleeting essence of life is made eternal in the heart of a rock. Sometimes, the original organic material completely dissolves away, leaving behind an empty space in the shape of the organism. This hollow imprint is called a mold, and if this mold is later filled with new minerals, it creates a perfect replica of the original form, a cast, a silent statue born of time and geology. Other times, for plants or soft-bodied creatures, the pressure from overlying sediment slowly squeezes out all the liquids and gases, leaving behind only a thin carbon film, a beautiful, delicate silhouette pressed onto the rock, a process known as carbonization. Think of the intricate veins of a fossil fern, a dark, ghostly image on a pale stone, a breath of ancient air made visible. Even amber, the fossilized resin of ancient trees, offers a unique window, sometimes perfectly preserving insects or tiny plant fragments, caught in a golden, transparent embrace for millions of years, a tiny, exquisite time capsule. These preserved remnants, these quiet echoes, come in many forms, each holding its own unique story. We call them broadly either quote 13 or quote 14. Body fossils are the direct remains of an organism, the sturdy bones of a dinosaur, the delicate shell of a mollusk, the sturdy trunk of a petrified tree, the intricate exoskeleton of a trilobite. They tell us about the anatomy, the structure, the very form of life that once graced our planet. They are the silent portraits from Earth's grand gallery of life, inviting us to marvel at the diversity and ingenuity of nature. Trace fossils, on the other hand, are the preserved evidence of an organism's activity rather than its body. These are the whispers of behavior, the fleeting moments of daily life made permanent. Imagine the fossilized ripple marks left by an ancient tide, the quiet paths of a worm burrowing through primeval mud, the delicate footprint of an ancient bird on a long-vanished shore, or even the fossilized waste, the coprolites of creatures that roamed before us. These are not the organisms themselves, but their silent actions, their passage through a world we can only dream of. They offer a profound sense of connection, a feeling that even the smallest, most ephemeral acts leave an enduring mark on the canvas of deep time. What did these ancient echoes tell us, you might wonder, as you softly contemplate their beauty? They are the keys to unlocking Earth's past, the tangible proof of evolution, the vibrant narrative of how life has changed, diversified, and adapted over billions of years. From the earlier single-celled organisms whose microscopic traces hint at life's very beginnings, to the majestic dinosaurs that once dominated the land, to the first delicate flowers that transformed ancient landscapes, fossils paint a vivid, if sometimes incomplete, picture of life's grand tapestry. They whisper of ancient climates, telling us whether a region was once a warm, tropical sea, a vast desert, or a lush, swampy forest. They reveal the depths of ancient oceans, the heights of long-eroded mountains, and the shifting coastlines of continents on their slow, majestic drift. A fossil fern found in Antarctica speaks of a time when that icy continent was green and temperate. A coral fossil high in a mountain range reminds us of an ancient sea that once covered that very spot. Each fossil is a tiny window, a portal through which we can glimpse the profound transformations our Earth has undergone. Consider the trilobites, those elegant segmented creatures that scuttled across the seafloor during the Paleozoic era, hundreds of millions of years ago. Their many forms, preserved in countless sedimentary layers, tell a story of early marine life, of diversification and adaptation in ancient oceans that were utterly different from our own. Or drift further forward in time to the Cenozoic era, the age of the dinosaurs. While the thought of these colossal beings might stir a momentary thrill, here, in our quiet contemplation, we see them not as fearsome giants, but as magnificent long-gone inhabitants of Earth, their fossilized bones a silent testament to a world that hummed with different rhythms, under skies that saw different suns. The delicate spiral of an ammonite shell, a distant relative of modern squids, speaks of vast ancient seas where these creatures drifted gracefully, their lives recorded in the intricate patterns of their growth. These quiet witnesses to deep time remind us of the immense patience of Earth, the slow, deliberate unfolding of geological and biological history. They underscore the understanding that our own existence is but a fleeting moment in this grand, continuous narrative. There is a profound comfort in recognizing this vastness, a gentle reassurance that life, in its myriad forms, has persisted, adapted, and flourished through countless ages, leaving its indelible mark for us to quietly discover. As you allow your mind to drift through these ancient landscapes, filled with the echoes of long-extinct beings, let the quiet wonder of it all settle deep within you. There is no urgency in this journey, only the gentle invitation to connect with the deep, enduring pulse of our planet. These fossils, these petrified memories, are not demanding. They simply are, waiting patiently to share their timeless truths. They are a reminder of the intricate beauty of life's journey, the relentless creativity of Earth, and the profound peace that comes from truly understanding the quiet, continuous story woven into the very fabric of our world. Let these ancient whispers guide you to a deeper sense of tranquility, a quiet appreciation for the immense and enduring narrative that is Earth's own.